We are doing shakedown here between the RCVs and the MET-D, and the experimental prototype office is actually doing a MUM-T experiment right now. So manned-unmanned teaming. So the MET-D is like the command ship of all these RCVs. This gives us the capability to allow us to actually see how it would actually play out in the battlefield. So we're going from, let's say, 6 vehicles total this time to 18. So it's 3 times the fun, 3 times the excitement.
The WMI is the interface between the soldiers and all of the new features and subsystems and technologies we're integrating into the MET-D vehicles. WMI is also the interface between the robotic control vehicle crew and them controlling their vehicles at the same time. So we have a couple flavors of WMI, one for the MET-D, one for the RCVs, really one for each RCV variant that we're going to be testing out there. So the WMI is based on what we call a menu book, or a booklet of how every button press, every trying to control any little facet of it should operate, and I'm here testing it to make sure it's doing what it should be doing. So it's a kind of a debugging effort, and all of the errors, all of the problems will go back to the software team, and they'll release kind of a final WMI in a few months, and then after that we're pretty much set on the WMI. So we're checking all the features, all the capabilities of it, and make sure it's doing what it should be doing. But the goal is to get it integrated into a newer vehicle coming out, to get the program managers to buy into it, which they seem very interested in doing it. Soldier feedback from our different SOEs that we've done, the soldier operational exercises, have showed glowing feedback from the soldiers. They really love the WMI and how it ties everything together.
C5ISR brings a unique capability to the circuit platforms for NGCV in particular, in that we provide under armor threat detection. It also detects at ranges that the human eye can't see. We have 4 sensors on 2 separate platforms, on both the MET-D platforms and the RCV platforms. The 4 sensors are an LRAS-3 system. We have a coupler system attached to that LRAS system. We also have a HFDL system, which is a hostile fire detection system. That hostile fire detection system senses RPGs, recoilless rifles, and ATGMs, those particular threats out on the battlefield. And then finally we have a pre-shot system, which senses things like scopes and threats that are on the battlefield with binoculars, scopes, rifle scopes, things like that. It will sense those optics in that sensor. We're going out to test range to stress our sensors a little bit. We'll have the MET-D position and we'll have the RCV position. And so then we can start looking. We can do threat detections. We're laying out what that test will look like. It's basically a performance test. We'll have threats in around. The key to C5ISR and this sensor technology and what we bring to NGCV is a capability that the soldier hasn't previously had. So it helps from a survivability standpoint, and it helps do that threat detection. So we uniquely bring that capability to NGCV program.
To improve the safety, to improve the lethality of the vehicles, and to make sure at the end of the day we bring all our soldiers home safe. That's really the main goal, is to give them a system that they have helped develop, so when we field it, it's something that is useful to them, it's something that they like, it's something that helps them in all their facets, and it's something that will make their job successful.
It's really to give a capability to the soldiers and allow them to understand the capabilities and limitation of this new technology and bring in robotics into the field, and to push the future in the realm of possible.